Hey, this is mean absolute deviation, or we shorten it up and call it MAD a lot. It's page 337, number 7 and number 9. So mean absolute deviation is the average distance between each data value and the mean, and it's a way to describe variation. And I'll explain that once we find the mean, because it's or the MAD, because it's actually easier to explain what the variation means. So number 7, I wrote the data. I have 3, 6, 7 pieces of data. The first step you're going to do is you're going to find the mean of all of those numbers. Then you're going to subtract each data value from the mean, and then you're going to find the mean of all the differences between the mean and each value. So I went ahead, I didn't order them from least to greatest this time, and I'm going to show you the difference and why it would be a good idea, but not necessary to order them from least to greatest, but it's a good idea to order them from least to greatest, especially when you're working with any set of data. So I found the mean of this data set. I added them up. It was 77. I divided by 7 because there are 7 pieces of data. That gave me 11. I wrote 7 11s, and then I subtracted each data point from the mean. I got 1, and then this is where the absolute comes in, because 11 minus 12 is -1, so I have to take the absolute value of that. The absolute value of -1 is 1. 2, 11 minus 14 is -3, absolute value of that is 3. Same thing for 15, absolute value is 4, 11, and 5. So then what I did to find the MAD is I took all of these numbers right here, and I found the mean of them. I added them all up. It was 16. I divided it by 7 again because there was 7 pieces of data. I even had to count that 0. I got 2.28, and I actually got a couple other numbers beyond that, but the MAD goes to the nearest 10th. So I had to round to the nearest 10th. So our MAD is actually 2.3. So what that means is the average is 11 plus or minus 2.3. That means that the average could be 11 plus 2.3, which would be 13.3, or it could be minus 2.3. So that means if, let's say you had an average of 11 minutes to swim, I don't know, in a pool. So the average is 11. That would range, that would vary, plus 2.3 and minus 2.3. So there's that variation explained. Number 7, have the blank canvas here. So the first thing I'm going to do is I order them from least to greatest. The next thing I'm going to do is I'm going to add all of these numbers up. Oops, 23 plus 30. And I am dividing by 3, 6, 8, 8. When I add all of those numbers up, I get 128, and there are 8 pieces of data. So the mean equals 16. So I have 8 pieces of data. So I'm going to draw, or write, 16 8 times. Now pause this video if I'm going too fast. I just try to keep it under 10 minutes so I don't have multiple parts to it. So now I'm going to take each data set and subtract it from the mean. (16 minus 7, 9. 16 minus 9, 7. 6, 2. Now here I'm going to get into my negative numbers. If you punch that into the calculator, you'll get a -1. The absolute value of that is 1. You'll get a -4. Absolute value of that is 4. you would get a -7. Absolute value of that, 7. And you would get a -14 here. The absolute value of that is 14. So I found the difference between every piece of data set and the mean. So now I'm going to add these numbers up and divide by 8 again to find the mean absolute deviation. So 9 plus 7 plus 6 plus 2 plus 1 plus 4. 9, 7, 6, 2, 1, 4, 7, 14 divided by 8. That is 50, and divided by 8 will give me 6.25. I have to go to the nearest tenth, so this is 6.3. So that means that the mean is 16, and it the data points deviate, or they vary 6.3 points away, going increase, and the 6.3 decrease. They can vary. All right, that is mean absolute deviation. Definitely watch this video over if I went too fast for you to get good examples down so you can refer back to them. And that is mean absolute deviation.